Greetings once again, guys. Let's have a look at our practice problem set number 7. And this is from the May-June 2024 exam. And this was question 3. So we are given an arithmetic sequence with T1 equaling 8 and T2 equaling 11. And the first question requires us to calculate for which value of n will Tn be 41. So let's go ahead and have a look at this. So what you should be able to see is that for us to determine what n is, we need to start by finding Tn. So we need to determine the general term first. And how we are going to determine this general term, we'll use what we are given here. So we are told that T1 is 8, and we know that T1 is always equal to A. And then we also told that T2 will be equal to 11. But what I know is that Tn in general will just be A plus n minus 1 times D. So if I find T2, what you will see, it will be A plus 2 minus 1 times D. So essentially T2 is A plus D. So it means I can now use the A and the fact that I'm given T2 to be able to determine D. So therefore, if you think about it carefully, T2 is equal to 11, but T2 is also equal to A, which is 8, plus D. So I can transpose now this so that I get the D as 11 minus 8. And when you do the maths, you should be able to see that 11 minus 8 will give you 3. So we're now in a position to go and have our Tn. So our Tn will be A plus n minus 1 times D, but we already have our A, which is 8. So we'll have 8 plus n minus 1. Our D, which is found as 3. So this means we'll have Tn equaling 8 plus 3n minus 3, which will end up being 3n plus 5. So now we need to ask ourselves, if we are given that Tn is 41, what is n? So we know that Tn is given by 3n plus 5, and we are given that this is 41. So we can transpose so that we can figure out what is n. So this means what we are going to have is 3n equaling 41 minus 5. Of which the answer we get becomes 36, okay? So what we end up having is 3n equaling 36, and we know that we are looking for n, not 3n, so I'll need to divide by 3, such that we find the n as 36 divided by 3. And when you divide 36 by 3, the answer which you get is 12. So therefore, n equals 12. That is what they were looking for. So let's go to the next question, 3.2.2. So we are told a new arithmetic sequence P is formed using the term position and the term value of the given arithmetic sequence. So for the new sequence, P8 is 1, we are told, and P11 is 2, and so forth. Then we are now asked to determine P41. So what we are given in this new series is that we'll have a term, call it P8, which will be 1, and we'll also have another term, call it P11, which will be 2. And now what we need to figure out is the question, which is A, which is write down the value of P41. And how we are going to do this is by quickly starting by figuring out what is this series going to be, or what is the general term going to be. So Pn will be A plus n minus 1 times D. So if we're looking at P8, we are going to have A plus 8 minus 1 times D, which is just going to give us 8 plus 7D 8 plus 7d, and this will be equal to 1. I'll call this equation 1. Then when we go to P11, it will be a plus 11 minus 1 times d, which will be a plus, if you observe carefully, 10d, and we'll call this equation number 2. Well, I need to equate it to what it is, which is equal to 2, and we'll call this equation number 2. So we have two equations which we can use to solve for what we need. Okay, so if you look carefully, we can do equation 1 minus equation 2, or equation 2 minus equation 1. So let's do equation 2 minus equation 1. So if you do equation 2 minus equation 1, what you should be able to see is that we'll have 10d minus 7d, or maybe let me write it in full to ensure that you do understand. So we have a plus 10d. On the left hand side, it will minus a plus 7d. And this will be equal to 2 minus 1. So essentially, we'll have 3d equaling 1. Now, let's go ahead and find what P41 is. So P41, if you substitute, you'll see you'll have a plus 41 minus 1 times d, which will just give us a plus 40d. So the question which we need to ask ourselves is, let me make some space. How can we use what we have to be able to determine what P41 is? Okay. And what I'm going to do is, for this P41, I'm going to say a plus, so we have 40. We need to try and find 40 using what we have here. And what you should be able to see is that I can say 7d plus, if I make this to be 7, it means I need to add a 33d for this to eventually match up. But if you look carefully, we'll have a plus 7d plus 33 is the same as 11 times 3d. Look at what happens. This portion here, if you look at equation 1, it is just 1. And then the inner part here is also just 1. So it means that our P41, if you observe carefully, it will be 1 plus 11 times 1. So the answer will just be 12. Okay, that is what our P41 is. You could alternatively go and calculate A and then eventually figure out what is D and then sub in on the formula to determine your P41. So let's go to question B. So this was 3.2.2 question A. So the question we're looking at now is B, where they are saying calculate the value of the first term of this new sequence. So we're looking at B. So essentially for B, they are asking us what is the value of A, which A, remember, is always given by T1. So what we found on the previous page was that you have A plus, let's go and have a look. If you look carefully, plus 7D equaling 1. But we also found that 3D equals 1. So which means we can actually solve for A. Now, if you look at this and we take this as equation 1 and this as equation 2, what you should be able to see is that from equation 2, we can go ahead and solve for D. So D will just be 1 over 3. And then what we are going to do is to sub D into equation 1. But if you look at equation 1, you can make A the subject by having 1 minus 7D. And this is still equation 1. So let's go ahead and substitute. So your A will be 1 minus 7 times 1 over 3. And this will just become 3 over 3 minus 7 over 3. Of which, when you do the maths, this will just become minus 4 over 3. So that is what we now have. So our first term, which is a, we have calculated it to be negative 4 over 3. So that becomes the value of the first term of this sequence.